Welcome back to The Explainer. Today, we're diving straight into the cutting edge of site mapping. We're going to completely demystify how aerial drone surveying works in what is literally one of the most uniquely challenging environments in the Americas, Costa Rica. So, whether you're a developer, an environmental consultant, or honestly, just someone fascinated by precision technology, we're breaking down exactly what you need to know about capturing real, actionable data from the sky.
Okay, let's dive into our roadmap for today. We're going to start by moving beyond standard satellite imagery, then we'll compare photogrammetry versus LiDAR. After that, we'll look at who actually uses aerial surveys, check out the accuracy and deliverables, break down the pricing and permitting rules, and finally, look at how this tech conquers Costa Rica's intense terrain. All right, Section 1, Beyond Standard Satellite Imagery. Let's talk about the raw power of drone data. You know, it's totally normal to have a bit of skepticism when you hear the word drone in a professional context. A lot of folks out there are still relying on older, traditional methods, and they kind of wonder if this is all just a flashy tech trend.
That skepticism usually boils down to one very common question from developers and landowners: what exactly is an aerial survey, and do I really need one? But here's the fascinating part. Once they actually see the data that these surveys produce, that question flips almost instantly. They literally stop asking, do I need this? And immediately start asking, wait, why didn't we do this sooner?
To really understand that reaction, just think about what so many projects mistakenly rely on right now: outdated satellite imagery. It's often cloudy, maybe 2 years old, and honestly, highly inaccurate for serious engineering. But professional aerial surveys completely change the game. We're talking about unmanned aircraft equipped with precision sensors flying these highly systematic patterns. They capture real, georeferenced data on demand. And the turnaround, it's incredible. You get accurate topographic maps and dense 3D models in just 72 hours. It's a total game changer for evaluating a site.
Moving right along to Section 2, Photogrammetry versus LiDAR. Now that we see the value, we really need to understand the tools, because knowing the core difference between these two technologies is absolutely vital for your project's success.
So the crucial starting point is photogrammetry. This is essentially a camera-based approach. The drone flies in a precise grid pattern, snapping hundreds of overlapping photographs. Then, specialized software stitches all those images together to create an orthophoto, which is, well, a perfectly corrected, measurement-accurate aerial image, along with a dense 3D digital surface model. This method is absolutely brilliant if you're dealing with open terrain. So early construction sites, agricultural fields, or high-end real estate marketing, photogrammetry is your go-to.
But what happens when you aren't dealing with open terrain? That is exactly where LiDAR comes in. LiDAR is laser scanning technology. Instead of taking photos, this sensor fires millions of laser pulses every single second and measures their return time with just wild precision. Why does this matter? Because it actually penetrates gaps in the vegetation to reconstruct the bare earth underneath. In a place like Costa Rica, with its dense forested hillsides in the Central Valley or steep Caribbean slopes, a standard camera is only going to see the tree canopy. It can't see the ground at all, unless, you want to send someone out there with a machete for 3 weeks. So if your survey involves forest cover, drainage systems, or cut-and-fill planning, LiDAR isn't just an optional upgrade. It is absolutely essential.
Section 3. Who uses aerial surveys? It's one thing to geek out over the tech, but let's look at the real-world applications and who relies on this stuff day to day.
Let's rapid-fire through some really cool use cases. In real estate, developers use this to verify lot boundaries and map out topography for building permits before they even break ground. In construction, site managers use it to monitor earthwork volumes, tracking exactly how much soil is being moved week by week, which prevents some really expensive surprises. In agriculture, think about the massive pineapple farms in Alajuela or the palm oil estates down on the Pacific coast. They use multispectral surveys to map crop health and spot stress zones. And for environmental consultants, these surveys are literally a lifeline for SATENA filings, giving them the exact topographic and drainage mapping they need for environmental impact assessments.
All right, on to Section 4, Accuracy and Deliverables. This is where we get into the nitty-gritty technical specs that the engineers are always asking about.
Now, what's really fascinating here is this single metric, 1 to 3 centimeters. When you use professional drone surveys with RTK GPS correction and ground control points, teams can lock in a horizontal and vertical accuracy of plus or minus 1 to 3 centimeters. To put that into perspective, that actually beats most traditional total station surveys when you're working on large sites. It easily meets the super strict requirements for construction earthwork and permit applications. No problem at all.
And the sheer amount of data you get back is comprehensive. A standard survey is going to hand you an orthophoto, a digital surface model, a digital terrain model, contour lines, and volume reports. If you go with LiDAR, you also get a classified 3D point cloud, and usually a forest density or tree height map. And the best part? All of this is perfectly compatible with your existing workflow. Whether you guys use AutoCAD, Civil 3D, ArcGIS, QGIS, or even just Google Earth Pro, you just drop this data right in and get to work. Okay, Section 5, Pricing and Permitting. Let's get to the bottom line, talk about the business side, and see how these flights actually get legally authorized.
Pricing out an aerial survey in Costa Rica really just comes down to a super clear 3-step formula. Step 1, the site area, measured in hectares. Step 2, the sensor type you need, so photogrammetry or LiDAR. And Step 3, the distance, meaning the travel time from San Jose. To give you a rough baseline, standard photogrammetry surveys usually kick off around $800 to $1,000 for sites up to 5 hectares. After that, it's just a simple addition of about $80 per extra hectare.
Of course, there are a couple of extras you might want to consider. Upgrading to that LiDAR sensor we talked about carries a tech premium of roughly 20 to 30% on top of the base cost. Also, if you're in a massive hurry, you can get a rush 24-hour turnaround for an extra $250. But keep this in mind. Yeah, LiDAR has a slight premium, but its ability to see straight through dense jungle canopy, that alone can save a construction project from some insanely expensive earth-moving mistakes later on. It is incredibly worthwhile.
So what about getting up in the air? From project start at day 0, the standard DGAC permit processing takes about 5 to 15 business days before official flight authorization is granted. DGAC, by the way, is Costa Rica's civil aviation authority. The really great news here is that licensed commercial operators completely handle this strict authorization process for you. Just a quick heads up though, if your site is right near an airport or inside a protected area managed by CNEC, it's naturally going to take a little extra time for those specific permits.
Finally, Section 6, Conquering Costa Rica's Terrain. Let's pull this all together and see how this tech operates in such a wild environment. This really brilliantly illustrates how versatile professional drone teams have to be down here. I mean, they're operating across all 7 provinces and literally every imaginable terrain type. We're talking about the dense urban grid of San Jose, the sprawling Pacific lowlands, the complex Caribbean river deltas, the super steep mountainous interior, all the way down to the incredibly lush, remote Osa Peninsula.
It all really comes down to this quote. Costa Rica's terrain is genuinely one of the most challenging survey environments in the Americas. You're dealing with volcanic topography, extremely dense tropical vegetation, really complex coastlines, and a tight permit environment. That combination means that professional, local expertise isn't just a luxury, it's an absolute necessity. You need the right gear, the proper legal authorization, and experienced operators to get precise data that you can actually defend in a boardroom. Which leaves us with this final, provocative thought to ponder. In a landscape this demanding, are outdated maps costing your project its future? Seriously, think about it. Relying on old satellite data in a rapidly changing, geographically complex country is just a massive risk. Precision aerial data is a project-saving tool, and as we've seen today, it's something you can request and utilize right now to guarantee your project's success. Thank you so much for joining me in this explainer, and hey, keep learning.